Hey everybody, I am so sorry that I wasn't in school today. I apologize. My son Bryce was not feeling well, and so I had to stay home with him again. But I will definitely be at school tomorrow unless I end up with the bug that he has. For solving logarithmic equations and inequalities, we are going to first start and think about what our relationship is with logarithms. If we want to go back to the original way that we had them set up, then some of you may need to put the log on the left-hand side because most of our problems were written in that way. And so when we set ourselves up, we remember that it is 4 to the x plus 5 power equals 256. So we can write that as 4 to the x plus 5 equals 256. So a little bit different than what we're used to, but we did really well with exponential equations. So hopefully we see that once we turn it from a log into exponential, this makes sense. There has got to be some way to break down the 256. And so we know 4 squared is 16 and 4 to the third is 64. So let's try 4 to the fourth. And if you do that, you are going to get 256. So 4 to the x plus 5 is equal to 4 to the fourth. Once we have the same base, then we are able to set our exponents equal to each other. Just a plain old equation. And we get x plus 5 equals 4. Subtract 5 from both sides, and we get x equal to -1. Yay! Now, as usual, we have to check our answer, and so if we plug in -1 plus 5, we are going to get a 4, and log base 4 of 256 is equal to 4, because that would mean that if we have a 4 over here, 4 to the fourth equals 256, and we have that right here. So we're good. Problem number 2, we are setting ourselves up the exact same way. We don't know what to do with logs, but we do know our logarithmic relationship. So one more time, I'm going to write it in the format that we are used to seeing, and then draw our relationship. We've got 2 to the 3x minus 5 equals 1024. Now, I don't know about you. 2 to the 3x minus 5 equals 1024. I'm not sure how many times we have to multiply 2 to get 1024. So I'm going to do like 2 to the 7th. And that gives me 128. I'm going to do 2 to the 10th. Ah, I got it. 2 to the 10th equals 1024. So I know that this is 2 to the 10th. So we can trade that in. We get 2 to the 3x minus 5 equals 2 to the 10th. Just like we solved any other logarithmic function, we have to break down the bigger number until we get it in the same base. And we can set our bases, or once our bases are the same, we can set our exponents equal to each other. We are going to add 5 to both sides, which gives me 3x equal to 15. And when I divide both sides by 3, then x is going to equal 5. And if we want to check that, 3 times 5 is 15, minus 5 gives us 10, and so if we have a 10, log base 2 of 1024 is equal to 10. Alright, now we are going to look at a couple more of these problems. we have variables in a different spot this time. Instead of them being in the the log being in what it's equal to and the variables in the front, these actually have what would be a variable in the answer. So we want to use our knowledge of logs that 3 to the 5th is going to be equal to 4x minus 17. So if we want to write that out, 3 to the 5th is equal to 4x minus 17. I don't know about you, but I don't know exactly what 3 to the 5th is, so I'm going to put that in my calculator and see that 3 to the 5th is 243 equal to 4x minus 17. The opposite is to add 17 to both sides. And we do that, we actually get what, 260? That would be nice if we get 260. And then we are going to divide both sides by 4, which gives us 65. We can plug this back in and check our answer. 4 times 65 is actually 260 minus 17 is going to give us that 243. So 3 to the 5th is equal to 243. So yay, here's our answer. Number 4, setting ourselves up in the same direction. 5 to the 5th is equal to 3 minus x. We have 5 to the 5th equal to 3 minus x. Then our first step is going to be, what is 5 to the 5th? I don't know about you, but I don't have that one memorized either. So it's 3,125 equals 3 minus x. Now at this point, we can subtract 3 from both sides, and that's going to give us 3,122 equals negative x. And then we are going to divide both sides by -1 in order to get just a positive x. And we get negative 3,122. Yay! Beautiful. And we should have checked it. 3 minus a negative 3,122 does give us that positive 3,125. So 5 to the 5th is going to be 3,125. Now, the next type of logarithmic equations we are going to solve are actually a little bit different. They are set up so that we have logs on both sides. It's almost as if our exponential equations, if you have the log of b to the x equal to the log of b to y, and b is a positive number other than 1, and that's real key. Everybody, we have to remember with logs that we're working with positive numbers. We do not have logs of negative numbers. So when we set these, because it's log base 13 and log base 13, we can actually set these equal to each other. So we get x squared minus 4 is equal to 3x. The logs kind of just cancel out for now. Now, in solving this equation, I hope some of you are starting to see some relationships here. We have a couple of ways that we can solve this. First, we have to get everything over on the same side. So we're going to subtract 3x from both sides. And that gives us x squared minus 3x minus 4 equal to 0. Now, there are a bunch of you who are great puzzlers, and I hope that you are recognizing that this falls in the category of solving with the puzzle. There are also some of you who love the quadratic formula, so I am going to do both. we can use a quadratic formula because this is a quadratic. It is ax squared plus bx plus c. So if you are not someone who likes the puzzle, if you would rather go the quadratic formula route, then that will work. Because we have a 1 here, we can take our puzzle and say something plus something equals -3, and something times something equals -4. Well, 2 and 2, we can't get a 3, but if we have a -4 and a +1, that is actually going to work. So we can set ourselves up that this is going to factor into x minus 4 and x plus 1 equals 0. When we take both of those and set them equal to 0, I'm going to take one of them up here. One of them is going to be x minus 4 equals 0, and we can add 4 to both sides, and we get x equal to 4. The second one that we have is x plus 1 equals 0. We're going to subtract 1 from both sides, and we get x equal to -1. Now, for my quadratic formula, you can go ahead and sing your song. It's been a long time. -b, plus or minus root of b squared minus 4ac of b squared minus 4ac all over 2a. I know you missed me singing that today in class, so we're going to go down here and we're going to say that our a is equal to 1 because we've got to get it in standard form. B is equal to -3 and C is equal to -4. So we have a -3, which becomes a positive, plus or minus, and I'm going to do some math up here. B squared is going to give me 9 plus, or pardon me, well, it will be a plus because we've got a -4 and a 1 and a -4. So that's actually going to give me -4 times -4, which will give me +16, and 9 plus 16 gives me the square root of 25 all over 2. Now we like this because the square root of 25 is, that's right, 5. That's one of our perfect squares. And so one of my answers is going to be 3 plus 5 over 2, which is 4. The other one is 3 minus 5 over 2, which is -1. So whether we factor or whether we use our quadratic formula, either way we're going to get the same answer. Now, as usual, we have to plug in our answers and see what we end up with. So if we plug in and check 4, then that's going to give us 4 squared minus 4, or 12, the log base 16 of 12, or pardon me, log base 13 of 12. Let me erase that so we can see it a little bit better. If we plug in on this side, then 3 times 4 is just going to give us a 12 as well. So first one checks. Yay, x equals 4 is a possibility. That one's good. That's one of our answers. But if we plug in a -1 squared does give us 1, but 1 minus 4 is -3. Can you have log base 3 of -3? Have we had any negatives involved? The answer is no. We cannot get a negative answer. We could not take the log of a negative number because negatives don't give us negative answers. They give us fractions. So this is not possible. With that not being possible, we immediately know when we plug in a -1 over here, we get the same thing. We cannot take the log of a negative number. So x equals -1 does not work. That one is thrown out, does not work. Our only answer for number 5 is x equals 4. We've got just a few seconds for the last one. I don't know if I can get it done. These have the same log base, so we get x minus 5 equals 3x minus 25. If I subtract x, that gives me 2x. Add 25, that gives